All right, the third example is one similar to one we've seen before, of figuring out how long it will take money to grow to a certain size. We have seen it with the continuous rate form problem before, but today we're going to look at how to do it with the ones that have the different n values. So this one will be, part B will be pretty familiar, whereas part A will be kind of new about how we're solving that, but using some of the lessons we know from before. All right, so how long will it take for $1,000 to grow? So this is my P value, what I'm investing, to grow to 5,000. So that's what I want to get out of that's what the amount I want in the end. Interest rate, so that's going to be 0.035. That's my R. And then here for part A, we get our n value will be 4. Okay. So I'm going to use this formula here for part A. So A is 5,000 equals 1,000 times 1 plus R, so 0.035 over 4 to the 4 times t power. Okay, so just like we did with the problems like this, we want to get t by itself. And the first thing we need to do is get rid of this 1,000. We are following SADMAP as we try to do this. And so I have this power, this base, and that's all in parentheses, so I can't get rid of that until later. So I need to get rid of any subtraction or addition, or any division or multiplication. So I do have some division or multiplication I can get rid of. So I'm going to divide this side by 1,000, and divide this side by 1,000. So that gives me 5 equals 1 plus 0.035 divided by 4, all to the 4 times t power. So the next thing I'm going to do is take this number and turn it into a variable or a constant. Just kind of like we did with a k value in example 1. I just don't want to write this anymore, and it's going to be a decimal. Maybe it's a little messy sometimes, especially depending on what this n value is. It can make this thing messy. If it was daily, dividing by 365 can make this number pretty messy. So I'm going to show you how to do that. So I'm bringing the calculator back up. So I'm going to type in 1 plus 0.035 divided by 4. Again, I want to make sure the calculator knows that that fraction is all together, so I put parentheses around it. And it gives me the value. So again, here's the number, and I could write that down. It's not that big of a deal to write that number like that down, but I want to show you this skill again. So here I'm going to store that, so STO, and you get to pick whatever letter you want. I always just pick A, most of the time just because it's right there next to the alpha button. So I'm going to store that as letter A. Again, whatever I do with A now would be assigned to that number. So next thing I'll do is, as you think about how you write this now, I'm going to call this 5 equals A to the 4t power. So it's just a good idea that, if you're going to do this in your calculator, to write down what letter you call this stuff. Okay. So this is just a number I didn't want to write down anymore, so I'm letting my calculator hold on to it while I do the math. So now I have a logarithmic equation, an exponential equation I need to turn into a logarithmic equation, and it's going to be base A. So here's another reason I didn't want to hold on to that number as a decimal, and definitely do not round it. It was something very close to 1, but it wasn't 1, so rounding it right now would be a really bad idea. So you'd either be writing a log of 1 log base 1.00875 or whatever it was, or what we can do now is just say, what's log base A? Of 5, that's equal to 4t. So of course getting t by itself would give us t equals log base A of 5 divided by 4. Well, how do we figure out what log base A of 5 is? Because A is not is not 10, it's not e, so we can't use that in our calculator. So that's actually, we're going to go and use the change of base formula, so that means that log of 5, or natural log of 5, depending on how you want to type that, or over log of a. Now I'm going to take that, that's just the numerator here, it's just that, and I need to divide that by 4. I'm not going to write it as another fraction, so I'll just write it like this. And so we can use our calculator to figure out what this is. Oops. Oh, technology. All right, so parentheses log 5 goes those divided by log alpha a, close those first set of parentheses, and divide by 4. So I get 46.2 years. So that's a pretty long time for that money to have to sit in that account. But you are asking it to be 5 times greater than when you put it in, without doing anything else to it. All right, second part of this example is a little bit easier. You guys have done a problem like this before. We're going to use the continuously formula, so that means we're looking at this one. So B. So A is still 5,000. P is still 1,000 times E to the 0.0. The rate is still 0.035, and we still don't know what T is. So you guys have already done problems like this before. So the first thing I want to do is get rid of the 1,000. Get rid of the 1,000. So that means 5 equals e to the 0.035t. And so we turn that into a logarithmic equation. Since this is base e, it's going to be natural log of 5 equals 0.035t. And then, of course, get rid of the 0.035. So t equals, and so I need to type this into my calculator now. So I'm going to type in natural log of 5 divided by 0.035. And that would take 45.98 years, which is really close to 46 years. So we can see that our money does grow a little bit faster with continuous compounding, but not that much faster. All right, and that's the end of that example.